Okay, let's take a look at a few graphs here. Okay, at this point I should have stopped video and started it back up again so that you can go ahead and copy this here. These are 4 examples of the major equations of lines that you'll be that you need to know about in terms of the slope. Okay, so we have this graph here. We'll call this graph 1, and we'll call this one graph 2. So we'll have something to refer to, and this one is graph 3, and this one is graph 4. Okay. Now, the main equation, when I was teaching, that I saw that the books like to refer to or play around with was the slope-intercept equation, okay, the y equals mx plus b. Okay, but again, it doesn't matter because really you are fooling around with the slope formula. So anyway, the slope-intercept equation here shows, this is a great demonstration of how a line, when it intercepts the y-axis, that point is where you'll have your y-intercept. That y-coordinate is your y-intercept, and that's what you plug and chug into the equation. So your y-intercept goes here, and if you know the slope, it goes here. So the slope of this line is m in our y equals mx plus b. Okay, that's just a typical equation. So graph 1 shows us the typical equation, okay? Okay, now graph 2 here shows us the line if it went through what is called the origin, which is where the x and y, see, I don't even have them labeled, okay? Sorry about that. Okay, where the x and y axes intercept is called the origin, and the coordinates at the origin is 0, 0. So the x coordinate is 0 and the y coordinate is 0. When that happens, notice that your y-intercept is 0 in this equation. So this ends up being y equals mx. So it's really, excuse me, y equals mx plus 0. Okay, so you're not going to have a 0 hanging there, so it's y equals mx. Okay, in graph 3, here we demonstrate if you have a line that has 0 slope. Okay, this is where m equals 0. Okay, so here the slope is equal to 0, and this is your y-intercept. Okay, so any line, any point along this y-axis would be can be a y-intercept. So for this equation right here, we have our y-intercept. So in our y equals mx plus b equation, if m is 0, then you end up with y equals b. Okay, so that means that you could have y equals 1, y equals 2, y equals 10, y equals -5. And in fact, y equals 0 is also a prime example of the y equals b equation. In fact, that is the x-axis. So a lot of times you'll see that in problems as well. They expect you to know that the x-axis, the equation for it is y equals 0. Okay? So next, in graph 4, we have our x-intercept here with a line here that's vertical, right? So we had a horizontal line here, vertical line here. What does that mean? That means that our slope is undefined. So here, well, I guess I could write it here. That's infinity, okay? But that's probably poor math language. But you get the point, okay? So here we have an undefined slope, and when you do, you end up with a x-intercept. So an equation like this right here, when it is parallel to the y-axis, then it could be x equals 1, x equals 10, x equals negative 4, and it also could be, guess what, x equals 0, which is what? The y-axis this time. So the y-axis, the equation for the y-axis is x equals 0. Just like the equation for the x-axis is y equals 0. Okay, that's a good note to take, okay? In fact, I'll write it out right here, the equation here. Okay, I'm going to make the board look real crowded, but this is good to know right here. Okay, a lot of times they'll give, I'm sorry. Okay, a lot of times they'll give you y equals 0, or they'll give you x equals 0, and they expect you to know what it is. Okay, so this right here, if you copy this down, this right here spells out pretty much everything. Okay, we may have a few more things to add here. Do we? Well, not really here. Okay, but I'd like to point out that the slope here, when it's slanted this way, okay, it's positive. When it's slanted this way, it's negative. Now, these are just examples right here, so you know you can have a slope that's positive. You can have a slope that's negative when it comes to this equation. And in fact, you know, let's write that out. Okay, so